just sent a question is this afternoon. I didn't send it last night.
Yeah, no, I mean, yeah, the one that you just sent this afternoon.
Right. Okay, yeah, sure.
So the answer to that is that they all have two. Yeah, all orbitals have two.
Right.
So it isn't
I see.
picture. I have a picture here. Just a second.
I thought the answer just I have to choose like a 4, like a S, P, D, F. I thought.
Let me see if I can show you this picture real quick.
Yeah. Okay.
Meadow, what's behind your head?
It's a TV, and then I have like little like peanuts Thanksgiving plates on that rack.
So
okay, sure.
The orbitals. Correct me if I'm wrong, Dr. Musk. But each one of these orbitals, right, has two.
Right.
Each orbital can hold up to 2 electrons. That's correct. So because of that, an S subshell only has 1 orbital in it because an S subshell can only hold 2 electrons.
Right.
And a P orbital, or sorry, a P subshell has 3 different P orbitals in it because a P subshell can hold up to 6 electrons. And there, Jennifer's holding up pictures of all of the orbitals in. Wait, you just moved it. Why'd you move it?
I'm sorry.
I was just going to reference that picture and then I was like, bye. So those 5 orbitals are the 5 orbitals that are part of a D subshell. And if you could imagine what a D subshell would look like, it would be if you drew all of those things smashed together in one place, which is why Dr. Musk doesn't try and draw D orbitals or D subshells. It's just too many different orbitals smashed together. All right. So I can draw an S subshell. I can draw a P subshell because there are only 3 orbitals in a P subshell, but D is just crazy. And then if you look on the next page, don't even look because it's just double crazy. But F subshells have 7 orbitals in them, and they have even crazier shapes than the D ones do. So there's almost nobody that remembers what all of those look like, other than the people who derived the mathematical equations that described them.
Right, but I think the question in the quiz was,
give me just a second, I'll get to it. I haven't even had a chance to check yet. I saw the email like 10 minutes
no problem.
ago.
Yeah. No problem. Okay, well, we'll go over it together.
Quiz, the last reading quiz in chapter 2, is that what we're looking at? 2.5 to 2.7?
Yeah.
Okay. I'm going to share my screen so we can all talk through it together. Oh, by the way, hi, everybody. Nice evening. Is it just
Good
me,
evening, Dr. Musk.
Like, did it level up for fall today? Did you wake up and like sort of feel it in the air? I'm chilly. I've been chilly all day today. So which
the question
which
2? The question 2.
Question 2.
Question 2 and the second question.
Okay. So which kind of orbital has a dumbbell-like shape? All right. Now, if you look at your pictures of what different kinds of orbitals look like, the S subshell only has 1 orbital and it's spherically shaped. The P subshell is the one that has the 2 lobes on it, kind of like a dumbbell. Even though I don't like the description dumbbell, for some reason all chemists use it. So I just sort of like go along with everybody else because I assume that it's just some sort of deficiency in the way that I see it, because it doesn't look like a dumbbell to me. There are no, like maybe like a double kettlebell without a handle or something. I don't know, whatever. So anyway, you can see in Jennifer's shared screen right now, it has 2 lobes, just like a dumbbell. Now, this is an important piece of information, all right? Which kind of orbital holds the most electrons? So it does not say which kind of subshell holds the most electrons. This is an important question, all right? Remember, a subshell is part of a shell and an orbital is part of a subshell, all right? So we go from the most electrons, like all the electrons in the atom can be split apart into individual shells. Each of those shells can be split into individual subshells. Each of those subshells can be split into orbitals. So at the level of orbital, all orbitals hold the same number of electrons. They can hold 2 electrons, no more, no less. Well, they can hold less, but they cannot hold more. As a matter of fact, I probably should reword this and say all orbitals can hold up to 2 electrons. Clumsy language on my part.
Right. I thought this is not one of the answer. I thought only SPDF. I see.
So an s orbital is just the only orbital in an s subshell. It can hold 2 electrons. A p orbital is one of the 3 p orbitals in a p subshell. Those can hold 2 electrons. A d orbital is one of the 5 orbitals in a d subshell. It can hold 2 electrons, no more.
Mm-hmm. Okay, but why said the most?
Because I was trying to trick you. That's exactly why I said which one holds the most. All right, because if you didn't know what orbital meant and you thought I meant subshell, then the subshells do hold different electrons. I didn't an F subshell holds more electrons than an S, a D, or a P subshell does. But I didn't say subshell, I said orbital. And all orbitals hold the same number of electrons.
I see. And I submitted last night, but I thought yesterday, today was 7th, so I thought that I submitted the day before the due date. So I tried to today did it. So I submitted yesterday, but today I submitted again. So it's a late submit. Said late.
Yeah, because it's late.
Well, I suppose I'll have to give you credit for it anyway. Just keep track of those due dates. And for some reason, like a number of people are not keeping up with Alex homework. So I have to send out a bunch of emails about Alex homework and about lab 1. Like out of our 48 people that are in all my sections, I had like, I want to say somewhere between 13 and 17 didn't submit lab 1. That's not a good way to get things rolling for the class, especially since like the experiments don't really get any easier. The lab 1 experiment was pretty simple. So if you're having issues with trying to finish an experiment, the best thing to do is try and finish the experiment a couple of days before Thursday. So if you have questions, you can hop onto my office hours and ask. I'm more than happy to help you, but I can't help you unless you let me know you need help.
And then are you waiting for those last couple of submissions on the lab 1 to?
No, I've started grading a Meadow. I just haven't got to yours yet. They go through alphabetically. I was grading some this afternoon, and I'll probably be able to finish grading all the rest of the lab 1s tonight. So you should get a notification when your grade comes in.
Okay, great. Thanks.
Okay? Yep. And another PSA, as long as I'm being completely pedantic and a little bit petty, try your best to make your PDF just one PDF file instead of a PDF for each page of your lab. It really does, like net, save me a lot of time if everybody turns their whole lab into one PDF file instead of a page for each one. Because then if I grade each page separately, I have to mark what points you miss on each separate page, and I can only look at one of those files at a time with the Canvas grader. So I have to scroll back and forth and like load one, then go back to the others to try and keep track of points. It's a pain in the butt. Whereas I can just scroll through all the pages if it's just one file. So anyway, that will help me a lot. And if you need help with like learning how to do that, There are lots of different apps that can turn all of your photos into just one PDF file. I think even most like new Android phones or iPhones can do it automatically. You can scan the pages using your camera app in your phone and just turn them into one PDF file. But if you need help doing that, I'm happy to help. Just pop onto my office hours.
And then I had another question. Do you have any like notes from what like common mistakes you've seen on like some of our like on our first lab? Because I haven't seen my grade on my first one, so I want to make sure I do it right.
You'll get it really soon. There haven't been any really common mistakes other than people submitting the lab without actually filling in the graph that you were supposed to fill in. So if you didn't fill in the graph that you were supposed to fill in, that's like a pretty reasonably high deduction. I think it's 10 out of the 100 points. So if it asks you to draw a graph, freaking draw the graph. All right. If you completed your assignment in like Word, for example, and you didn't want to hand draw your graph, you could definitely graph that material using Excel instead. And it actually looks even nicer than if you graph it by hand. And you would just have to paste it in at the end of the document. And that's perfectly fine as well. But I need that graph because you're supposed to not only graph so that you show me you know how to graph that data, but also you're supposed to use it to do some interpretation. So I can't tell that you've done the work unless you turn it in. That, and I think a couple of students have messed up trying to figure out extrapolation from the graph. So like it asks you to estimate the volume that the balloon will be when the temperature gets to 1,000 degrees Celsius. And some students mess that up. Basically, you have to like look on the line and see once your temperature gets up to 1,000, how high does your volume get? Does that make sense? So you have to read your graph in order to solve that answer. And some people messed up a little bit with that one. But I haven't seen any really common errors in thinking other than messing up the interpretation of that graph or just not doing the graph. That's it. That's all I've seen so far.
Is it too late to correct your graph even though you submitted it?
Correct your graph? Like do the graph, you mean?
Yeah, do the, yeah.
I mean, if you can get to it before I grade your lab, and if I see that it was submitted late, I don't care about that. I'll grade it for this week. That's fine. So if you want to submit a different version, that's perfectly fine.
Okay.
I guess I didn't think about that with my graph. I just put a dot on the point, you know. I mean, did you want us like drawing a line?
You don't have to. No, as long as I have the points, that's fine.
Oh, okay.
But in order to do that interpretation where you extrapolate what your line means, you have to think where the line would go anyway, even if you didn't draw it in. Does that make sense?
Mm-hmm. Yeah.
Does everybody know how to use Excel to make a graph? Maybe I should teach everybody really quick because it's actually a pretty amazing tool. I'm going to stop sharing for a second so that I can get Excel set up.
About that, I got notification from other teachers that when I sent in my PDFs that I was missing pages, even though in my files it says I have them all, but for some reason sending them off to you guys is saying that you're just not getting them all. So I'm a little worried you may have not got my whole.
I'll check if you're missing pages. I'll let you fix it, Haley. Okay.
So don't use the app when you're doing stuff like that. The app has problems. Definitely use laptop or Windows or Mac with Chrome browser. Then you have the best chance. But yeah, the app is dropping stuff left and right.
Are you talking about the Canvas app for phones?
Yeah. We shouldn't be using the Canvas app for anything except maybe checking your grades.
Yeah.
Yeah, that was my issue, is that I did use the Canvas app for everything, but my internet wasn't working like for 2 whole days, so I was having to use my phone to submit everything.
Right. Yeah. The app's just it's not fully functional, and they don't bother to tell us that until it's too late. But now we know that. So
Haley, the other thing that you can do is if you have to use your phone, use your browser in your phone to log into Canvas and submit that way instead. Does that make sense? So that's the workaround if you have to use your phone for a submission, is submit it through Chrome on your phone instead of submitting it through the Canvas app. All right, so I am gonna really quick do a version of lab 1 where I change my volume and see what, change my temperature and see what happens to my volume. So I'm logging in to Beyond Labs. I'll share my screen in just a second. So I'm just going to get a few data points so that we can do a little bit of graphing. And also I'll show you some really cool stuff that you can do using Excel. So using Excel, we can do even better than just estimating what my volume of the balloon is. We can solve for it using a line of best fit, and we don't have to solve for that line ourselves. Excel will do it for us. All right, so I'm going to share my screen. The cool thing is, in terms of like what we've covered in recitations this week, other than doing a lot of practice with ionic compounds that have polyatomic ions in them, we have really done a good job covering chapter 3. So if you watch the recitations from earlier this week, there's a ton of good practice there if you haven't come to those. So definitely check them out, because there's a lot of good practice problems hidden in those. But we'll do more practice with chapter 3 with naming ionic compounds tonight. But I just want to like give you just a quick tutorial on how to use Excel to make graphs. The other great thing is, I don't know if you know this, but the entire Microsoft Office suite, you guys already have paid for it as your access, like as part of your tuition. So you can all download the entire Microsoft Office suite from, I can't remember exactly where you guys get it. Jennifer, do you know how they, Renee, do you know?
No, sorry, I had a question.
Okay.
Just go to the MySVC page. It's on there.
Sweet. All right, Renee, question.
Yeah, sorry. So I have a question about just, can you please tell me when you post the recitations? Like, are you posting Monday all 4 days, or are you posting them? Because I'm seeing, it looks like this week you posted 3 of them, so that tonight's would be posted also. So you're posting all of them, but like last night when I went on, 5, 6, and 7 weren't there.
Right, yeah, so it depends. Sometimes they take a really long time to process on YouTube before I can pop them out.
Okay.
And sometimes they process really quickly.
Okay.
So every once in a while, when I throw them to YouTube to process, like I don't have enough time to sit around and just wait for them to finish queuing.
Sure.
So I'll forget that they're there, and then I'll look and be like, oh shit, I haven't posted a recitation in a couple of days, so I'll throw them all out, you know?
Okay.
So I try and keep them as up to date as possible. Sometimes they're a couple of days behind. I apologize about that.
Okay, no worries. It was just the timing this week. I was like, oh, I could really have used the, but it was fine.
If you didn't get some points that you think you could have gotten with that recitation, I'm happy to give you an extension if you need to do a topic or something on Alex.
Oh, okay, thank you. Well, I emailed both you and Jennifer last night, and Jennifer, it was late and I had just gotten back from a class.
Yeah,
but
I got it this afternoon when I started looking through things, and so it seemed like Jennifer had already.
Yeah, so it worked out okay, thank you. And I'll ask my question later, so.
Okay.
I mean, about the problem I was having last night.
Sweet. Let's take a look at Excel really quick. How many of you guys have used Microsoft Excel before? Logan says yes. Rafonso Meadow, yes. Brandon, can you give me a thumbs up or a thumbs down? Jennifer is a yes. Thumbs up. Okay, sweet. Oh, Haley's a thumbs down. That's fine, Haley. It's really, really easy to use. All right, like stupid easy and very powerful. So if I wanted to make an XY plot of a set of data, I am going to put my X coordinates in a first column and my Y coordinates in a second column. All right. Oh, wait, you can't see the screen because I haven't shared it yet. So now I'm going to share my screen. So I'm going to put my X coordinates in a first column and my Y coordinates in a second column. So where am I getting these coordinates? Well, I'm going to get them by basically doing a short, stupid, small version of the lab that we did last week. All right. So I am going to change my temperatures, and I'm going to do temperatures that you guys haven't done. So I'm going to start at 170. And at 170 degrees Celsius, and I'm gonna make this smaller so that I can see both things at the same time. No, what? Why is it not letting me get rid of all this dead space on the side? Beyond Labs, you are evil.
Yeah, I tried that one too. It doesn't make, like, the size doesn't change.
So I guess they're following along with the way that Microsoft does their updates. Every time they update any of their applications, they get less good and less user-friendly. So I guess Beyond Labs is going the same route. All right, so 107, and we can even keep track of our scales here. So we are looking at temp in degrees Celsius on the X and volume in milliliters. Remember, centimeters cubed and milliliters are the same thing on the Y. So at a temperature of 170, my volume is 1,819 milliliters. All right, and then I'm going to increase my temperature to 270. And my volume is now 2,229 milliliters. I'm going to increase to 470. Remember, I'm not doing the exact sizes that you guys did. And then I'll increase to 670 just to be silly, or let's do 770, whatever. And my new volume is 4,281 cubic centimeters. All right, so let's say that I wanted to graph these XY data points. The way that I would do that is I would highlight all of that data, including the scales, all right, so including the headings, and I'm going to insert, and here are the different types of charts I can insert. Right here's the one that I want, so an XY scatter. Now you can have Excel draw a smooth line between each point. I definitely prefer to just plot the data themselves, all right? So sometimes Excel will realize that these are supposed to be the labels for your axes. It doesn't look like Excel did a very good job of that here. So let's change our title to mean something, or to say something that we want it to say. And I'll make this a little bigger so it's easier to see. So I've given my chart a title, and I can go to add chart element and then axis titles. So for the horizontal axis, remember, these were our temperatures in degrees Celsius. And in axis titles for the vertical axis, these were volume in milliliters. Oops. Now, the other thing that really annoys me about this plot is that the space is not used very efficiently. All right, so you can see that there's a lot of space down here where there are no data points at all. We can fix that by, instead of letting it auto scale the y-axis, if I right click on that y-axis, and I don't know exactly how to do this with Apple computers, but I'm sure it's very, very similar. I'm going to go to Format Axis, and instead of having 0 be my minimum, I don't have any data points under 1500, so let's just start our graph there so we don't have so much dead space. All right, so you don't have to do all these things, but those are ways that we can make our graph look a lot nicer. That's a really nice plot of temperature on the X and volume on the Y. So let's say that we wanted to do some prognosticating using this set of data. In other words, what if we were trying to predict what would the volume be if our temperature was 1,000, which is like all the way over here someplace, all right? we could try and draw a line and see where it ended up, but our graph isn't quite that big. So another way we can do that is actually solve for the equation that fits this linear set of data the best. And the way we do that is by right-clicking on one of the data points and then going to add trend line. Now, the cool thing is Excel analyzed that set of data and said, I think that data is linear. So it picked linear for us. If you had a data set that fit exponential or logarithmic or polynomial, most of the time Excel will find out what the best fit curve is and will give you that as your first option. So the other thing that we can do is we can display the equation for this line on our chart. If I click here, it tells me that this is the relationship between temperature, the x coordinate, and volume, the y coordinate. So if I wanted to figure out what my volume was at a temperature of 1,000, I would substitute 1,000 in for x and then solve for y. The other thing that it can tell us is how good the data or how well the data approximates a line. So the R² value tells you how linear your data set is. The closer to 1 it is, the more linear your data. Hey, look, our data is perfectly linear. Great. So there I have a really, really nice graph. All right. Now, if I was submitting this lab and I didn't want to hand draw the lab, what I would do is I would click to highlight this chart and Control-C to copy it. And from there, I could open up a new Word document, or I could open up the Word document that I was using to write my lab in, and then I could Control-V to paste it. So I could literally paste that graph and resize it and put it anywhere I wanted to in my Word document to be included and graded. That's the way I would handle if I had to draw a graph for one of the labs. It's pretty fast, and Excel has lots of tools that make graphing a lot nicer than having to draw them by hand. Any questions about that?
So if yours has been already graded, could you fix your graph still? Or could
Fix, by fix, you mean like actually
yeah,
put a graph
yeah,
in there?
yeah.
If it's already been graded, yeah, if you submit it again, I'll grade it and give you the points for the graph.
Okay, okay.
So before we go on to more practice with naming ionic compounds, using polyatomic ions as part of those names, remember there's a short list of polyatomic ions that you will be responsible for remembering the name, formula, and charge of. All right, so that list was given in our last recitation, the one from yesterday. If you want, we can go over the list really quick and use it some more today as well. All right. So remember what a polyatomic ion is. A polyatomic ion is just a small, I'll write the name first, a polyatomic ion. So poly means many, atomic, atom, ion means something with a net charge. So a group of atoms with a net charge. That's what a polyatomic ion is. So there's a short list of these that I want you to remember the name, the formula, and the charge of, because they're so common, even in the things that we buy at the store, in like how we fertilize our fields. So nitrates and phosphates are common parts of like agricultural waste that we keep track of. There, sulfates and sulfites occur in foods in varying amounts. So sulfites are the polyatomic ion that if you have too many of them in the way that your wine was preserved, they can give you headaches. So these are really common in everyday products. All right, this is a short list. My majors class, I make them memorize about 40 of these. All right, that seems like a ton, so don't think I'm cruel. I'm actually not. There are rules that help us cut down that number, so we sometimes get 2 or 3 or 4 polyatomic ions, sometimes even up to 12 polyatomic ions for the price of one. Like if you remember one of them, you'll automatically remember all the others if you remember the rules. So I'll teach you one of those rules that'll help us cut down on the amount of memorization that we have to do. All right, so let's organize these by the atom that is sort of the central atom. All right, so carbon containing polyatomic ions that I want you to remember. One of them is C2H3O2 with a -1 charge. So that polyatomic ion is the acetate polyatomic ion. In your book, it may be written as CH3COO minus or CH3CO2 minus. In each case, if you add up all the atoms, it's the exact same chemical formula. They're just organized in different ways sometimes, so no big deal. Any one of those ways that you want to use to write acetate is perfectly fine with me. This is the way that I prefer, unless I'm doing organic chemistry, and then I prefer this way. But I recognize all of them. Did somebody have a question?
I have a quick question.
All right.
So I'm just finishing up with chapter 2. You're into chapter 3 with this?
Yeah.
Okay, so it's different than the calendar. Maybe I should go back and like I haven't had, you know what I mean? Like the calendar, the lab 2 is due tonight. The homework 2 chapter 2 was due last night.
Yep. And we're covering chapter 3 right now. Chapter 3's homework isn't going to be due till next week. So we're covering new material right now. And
okay.
Does that make sense?
Yeah. 3 what?
I don't know, three something. I don't keep track of the parts of chapter 3. So
okay.
Chapter 3 really just has a couple of really big jobs for us to learn about. Okay. We have to learn how to write ionic compounds with the correct formula. Gotcha. We have to learn how to name ionic compounds correctly when we have their formula. Okay. So how the parts of that chapter break down, like the individual videos in the chapter module are broken down by part like that. But that's not normally the way that I teach when I'm hanging out with you guys.
Okay. All right. Thanks.
You're welcome. But definitely our recitations were a little farther ahead because I want you guys to like have exposure to this, you know, before end of next week, we're taking our first exam, right? So hopefully next week we'll cover some of chapter 4 because we got to keep on going, but hopefully we'll have time to also do just a little bit of review, and you guys will have some time over the weekend to think about and process chapter 3 so that you can ask some final questions before you take your first exam. But if you look on so give me just a second here. If you look on the Canvas dashboard, our schedule says that we're covering chapter 3 this week. So if you're wondering like what kinds of things you might expect to see in recitations, first of all, these recitations, they're completely optional. You never have to come to them if you don't want to. And on top of that, they're completely customizable by you guys. So if you come to recitation and you have things that you want to talk about, like we don't have to cover the things that I have in my brain because maybe you don't need help with those things. All right. This time is customizable. It's meant to help you guys. But the things that I'm thinking about helping you with each week, if I look at the tentative course schedule, it's a schedule by week. So if we look right here, the week starting 10/5, which was this Monday, ionic compounds, chapter 3 is what we're covering this week in terms of like what we're learning about.
Okay, I understand that. It's just that it's a little bit confusing to me to be off sync with the homework and the lab, but I'll just adjust.
Well, wouldn't you want to cover in recitation the stuff before the homework was due?
Well, actually, I mean, so far for me personally, it's been, the book isn't particularly helpful. What's helpful is your videos. And then I
Yeah.
have, like, I've been working and haven't been able to come to recitation this week, but so it just would be more important to me to have things in sync. But that's just me.
I just don't know what you mean by in sync. To me, it feels like we are in sync because we're learning about chapter 3 before the chapter 3 homework assignment is due. So we learned about chapter 2 through the last part of week 2 and at the very beginning of week 3, and the chapter 2 assignment was due in the middle of week 3. So our recitations over material tend to happen a little bit before the assignment is due, because I want you guys to have the chance to ask questions.
Like, I just need to do the homework in the lab essentially ahead of what you have on the calendar, because you have the tentative course schedule, but then you have the calendar, the course calendar. And so they're not very much in sync. Do you know what I mean by the course calendar? Like if you just click on the little calendar icon and it shows what comes up, you know, like this week it's just showing, it's not showing anything to do with chapter 3. But
so
that's
the course calendar just has due dates on it, right? So we'll have already covered those things in class before we have an assignment due.
Exactly. That's why I say I'm behind. Like I just need to be doing essentially, you know, what's on the calendar for, you know, this week should have been done towards the end of last week, even though it's not due until this week, because makes more sense to, you know, be reading with what you're doing on recitation that week.
Yes.
Yeah.
Okay. I understand what you're saying. And yes, I agree with you. I just don't know how to, like, I can't make my course calendar not be the due dates for things.
I totally understand.
Okay.
Yeah. And I joined the class late because it was full. So I probably missed some of this stuff too.
Welcome. So if you need an extension on anything to get caught up, I'm happy to help you with that. Okay. Just shoot me a text message or shoot me an email. Or if you need help, like outside of recitation to get caught up with stuff, come to office hours and we can barrel through some material and talk through things together.
No, I appreciate that. I'm caught up to where things are due and everything's submitted. It's just like I realize with what you're talking about, I'm like, I have no idea what you're talking about because I haven't looked at it yet. So
sweet. Yeah. So the recitations from earlier this week, those will help you catch up. And also, like, maybe this won't make much sense. So the polyatomic ion list may be a bad place to jump in. Yeah. But once we start using these, then it may make more sense. Okay.
Okay. Thank you.
Yep. All right. So really quick. CO3 with a -2 charge is the carbonate polyatomic ion. CN with a -1 charge is the cyanide polyatomic ion. And we'll do our first 2 for 1 here. If you remember carbonate, it's really easy to remember HCO3 minus. So if we add an H plus to a CO3 2 minus, it cancels out one of those negative charges. So HCO3 minus is often referred to as the hydrogen carbonate ion, or even more commonly, it's referred to as the bicarbonate ion, like in sodium bicarbonate, which is baking soda. So those are our carbon-based polyatomic ions that I want you to remember. Now we'll look at a few that are nitrogen-based. And the first one of these is really important for you to write down because it's one that's not in the list in the textbook. And I think it's completely lame sauce that they didn't put it in there. The reason why I think it's lame sauce is because out of all the common polyatomic ions, it's one of the only ones that has a positive charge. So NH4 plus is the ammonium polyatomic ion. And then we have a couple of very closely related polyatomic ions, one of which is NO3 with a minus charge, and the other is NO2 with a minus charge. So remember I said there were rules that cut down how much we have to memorize when we memorize these. NO3 with a -1 charge is the nitrate polyatomic ion. NO2 with a -1 charge is the nitrite polyatomic ion. So the first big shortcut here is that if there is an 8 version of a polyatomic ion and an ite version of the polyatomic ion, the only difference between those two is when we go from the 8 version to the ite version, there's one less oxygen in the ite version. Same formula, same charge, just one less oxygen. So if you know nitrate, then you know nitrite. We have a very, very similar situation with the sulfur polyatomic ions that we have to remember. SO4 with a -2 charge is the sulfate polyatomic ion. Note that the 8 suffix doesn't always mean a certain number of oxygens. Nitrate only has 3 oxygens, sulfate has 4. But it is universal that if there's an 8 and an ite version of the same polyatomic ion, the ite version always has just one less oxygen than the 8 version. So sulfite is SO3 2-. And then finally, a couple of phosphorus containing polyatomic ions. Phosphate has the chemical formula PO4 with a -3 charge. And phosphite, PO3 with a -3 charge. So as long as you are rock solid on what nitrate's formula and charge is, what sulfate's formula and charge is, what phosphate's formula and charge is, you get nitrite and sulfite and phosphite for free. It's 2 for 1s. So let's count up the number of ions that we have to memorize. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. But in reality, you have to memorize 8 different formulas and charges for polyatomic ions. The other 3 are freebies if you remember how to turn an 8 polyatomic ion into an ite polyatomic ion. So now that we have those formulas and charges for some polyatomic ions, I want you guys to write me formulas for a couple of different compounds, all right? And because some of you haven't done too much writing with ionic compounds yet, I'm going to give you a few examples that are from earlier as well, all right? We'll mix polyatomic ions in, but not all the examples will have them. Strontium iodide. Let's try potassium carbonate. Aluminum sulfate, and tin for selenide. That would be an incredibly toxic and incredibly smelly compound. So take a few minutes and see if you can find the correct formula for each one of those. So remember, if we are predicting the correct formula for an ionic compound, we have to know what the charges are for the two ions that are put together in it. And in this case, we call this a binary ionic compound because it's just one where we combine two different elements. So let's look at where strontium is on the periodic table. I see strontium right here, part of group 2, and it's a metal. We know that metals lose their valence electrons when they become ions. So a group 2 metal will have 2 valence electrons. So we should expect that strontium would have a +2 charge as part of an ionic compound. That doesn't look very good, so I'm going to write it again. Much better. All right. So strontium's a +2 when it's part of an ionic compound. Now, what about the nonmetal iodine? Iodine is a group 7 nonmetal. We know that nonmetals gain electrons until they have 8 in their outer shell, or until they have what we say a full outer shell, which most of the time is 8. So in order to have 8 electrons in its outer shell, group 7 means that iodine already has 7 valence electrons, 7 outer shell electrons. So that means we need to gain 1 more electron for iodine to have 8 in its outer shell, just like the next noble gas in that row, xenon. So we would expect iodine to have a -1 charge when it's part of an ionic compound. Now, the rule for writing the correct formula for ionic compounds is we know that the charges in ionic compounds have to balance. So if we have +2s for our strontiums and -1s for our iodides, the correct formula for strontium iodide must have twice as many iodines in it as it does strontium. So that is a balanced charge on each side. A +2 balances out with 2 -1s. Notice that when we write that formula, the charges aren't included because they've canceled each other out. We have to remember that that strontium is a +2 charge, and each one of those iodines is a -1 charge. So now for potassium carbonate, let's write down what each of the ions is that we're putting together here. So potassium is the ion that we get from the group 1 metal potassium. So potassium's group 1, it has 1 valence electron, which means potassium should have a +1 charge when it's part of an ionic compound. We're combining that with the polyatomic ion carbonate that has the formula CO3 with a -2 charge. In order to charge balance, it looks like we will need 2 potassiums per every 1 carbonate in that formula. So the correct formula would be K2CO3. That's charge balance. Note that that CO3 still has a -2 charge in there. We don't write it because it's balanced out with the positive ones from each of the potassiums. You have to look at that ionic compound formula and realize where the charges are at. Each of those potassiums is a +1, and that carbonate is a -2. So somebody want to help walk me through aluminum sulfate? How do I figure out the charge of aluminum in aluminum sulfate? Silence, nobody drank their coffee. What's the charge of aluminum in an ionic compound, and how do I know?
3+.
Well, don't sound so confident looking.
3+.
Okay, it is 3+. So how do you know it's 3+?
It's in group 3A.
There we go. So there's aluminum. It's in group 3A. We know that metals lose their valence electrons, and things in group 3 have 3 valence electrons. So there you go. You can be completely confident that aluminum is going to have a +3 charge as part of an ionic compound. Good job. And sulfate, we're just learning those polyatomic ions. So look back in your list and realize that the sulfate ion is SO4 with a net -2 charge for all of those atoms. So how can we create a charge balanced ionic compound between +3s and -2s? We're going to have to go with a common multiple. If we have 2 of those aluminum +3s, that'll give us a total of +6. If we have 3 of those sulfates, that'll give us a -6. That's charge balanced. So how do we write the formula for something with 2 aluminums and 3 sulfates? The aluminums are easy. We just say Al2. The sulfates aren't that easy. Whenever we have more than one polyatomic ion in an ionic compound, the way that we write that is by putting the polyatomic ion, the entire thing, in parentheses, and then using another subscript to say how many of them we have. So this is how we would say that there were 3 sulfates along with those 2 aluminums. So another name from earlier in the week, there are some metal ions that have the fortunate or unfortunate, depending on how you look at it. The fortunate thing about them is they can have more than one possible charge in an ionic compound. So for metals that can have more than one charge in an ionic compound, we have to specify what their charge is in the name. And we do that by writing the charge as a Roman numeral after the name of the metal. So tin 4 selenide right away has told us the charge of tin. It tells us that tin is a +4 in this compound. And selenide, if we look for where that might be, it's probably the shortened version of selenium. So I guess selenium is our nonmetal. Selenium is a group 6 nonmetal, which means it needs to gain 2 electrons to have 8 in its outer shell. So we would expect selenium to have a -2 charge whenever it's in an ionic compound. Charge balancing means that we should have 2 seleniums for every tin in this ionic compound. Notice that I didn't put that in parentheses. I didn't need to because I'm only doing 2 of just that element, not 2 of an entire polyatomic ion. Were those useful? Helpful? Renee, are you still completely lost, or are those examples starting to help some?
They're starting to
Yes,
help them. They're starting to have some things.
So what I'm going to do now is I'm going to write a little bit longer version of some examples. And honestly, this is exactly what this part of the exam is going to look like. On the exam, you can even see, all right, I'll just go ahead and show you guys one more time because not everybody has looked at it yet. One of the cool things about Canvas is we can spy on you and tell when you've accessed certain parts of the Canvas page. Not everybody has downloaded the sample exam 1 yet. What are you thinking? If you haven't downloaded the first exam, like it's literally an old version of the exam that I've used for this class. What better study tool could you have to see what types of questions to expect than an actual old version of one of my tests? All right. So I'm going to show you where it is one more time. That's not where it is. Go away. All right. So if I go into student view here, if I scroll down, and I know there are lots of modules, but I can't think of a way to make the front page smaller. It's just, it gets too crowded if I try and put more than one chapter in the same module. But if I scroll down past lab activities, past all the class videos, hey, there's practice exams. You can open exam 1. And this is literally an exam 1 that I have given for my 121 class before. All right. So in that exam, right there, question number 20, I guarantee you there will be a question exactly like this on the exam, exactly like this. It'll even have the exact same text. If I give you a name, you give me a formula. If I give you a formula, you give me a name. All right. The only thing that's going to change is you won't have these 10 examples anymore. There'll be 10 different ones. It's really fun for me because I mean, I can write examples like this all day long. So I'm going to give you some names and I'm going to give you some formulas. And whatever I give you, you give me the opposite thing. All right. Excuse me. All right. 4 names and 4 compounds. So you give me 4 compound formulas and 4 names. Ahem.
Does zinc have a 5+ charge?
The real question is, does it matter if we want to name that compound?
No.
And no, zinc does not have a +5 charge. As a matter of fact, from H, you could tell me what the charge of zinc is by looking at what it's with. So what is zinc with in formula H there?
Sulfate.
Yeah. What is sulfate's charge?
Oh, it's a 2+.
Well, you don't get ahead of yourself, right? So what is sulfate's charge?
2-.
Good. So if sulfate's charge is a -2, that must mean that zinc must have the exact amount of positive charge to balance that out. So that's how we can tell that that zinc is a +2. But when we name this compound, because zinc is pretty much always a +2, we just call it zinc sulfate. We don't have to say zinc 2 sulfate because chemists realize what the charge of zinc is. Isn't that weird? So for the transition metals that always have the same charge, most of the time we leave off their charge. That can be kind of hard because if I gave you the name zinc sulfate, that would probably be ambiguous because you wouldn't know off the top of your head what zinc's charge was. So guess what? I'm not going to give you an example like that on the test. That'd be mean. I'm not mean. Jennifer, you're hauling through them. I love it. It's like, I didn't mean to show everybody that.
Sorry.
No, it's okay.
That's okay. You catch
It was
my
good.
mistake.
I was keeping track of how long I should be waiting. I get really impatient when I give students a bunch of problems. Like, I want to be done with them in like 2 minutes, and it takes time to work through them.
That was not intentional.
It was funny. I was cracking up. So let's start talking about a couple of these. All right, so a little confession time. One of Dr. Musk's biggest flaws, I don't know why I just decided to go third person there. So one of my biggest flaws is that I get excited by hard chemistry problems, which means that oftentimes when I'm writing a test, I have to very actively stop myself by writing one of the hardest questions for the first one on the test, because those are the questions that I think are the most fun. And there's a psychological thing when you're writing tests, which you're like supposed to write a couple of easy questions first to let people get their feet under them and build a little confidence before you give them the really hard ones, right? So anyway, I gave a pretty hard one right at the beginning here, but I'll try not to give the hardest one on the exam to be question 1, all right? Just saying. It's hard because here, both of these things, both the positive ion and the negative ion, are polyatomic ions. So ammonium is in our list. Now, we haven't talked about how you're going to memorize these yet. I don't want to be over prescriptive, but for most students, doing flashcards for these is a great way to memorize them. All right, I highly recommend that. Sulfite is SO3 with a -2 charge. So in order to charge balance, it looks like we're going to need 2 ammoniums for every 1 sulfite in the formula. So since there are 2 ammoniums, we're going to put ammonium in parentheses. Say we have 2 of them, and then add the polyatomic ion sulfite. So polyatomic ions only go in parentheses if there's more than 1 of them in that formula. That's it. All right, that's the rule. Now, I did this second example for a specific purpose. The reason why is students often ask on exams, does spelling count when I'm naming my ionic compounds? And I say sometimes. So the reason why I have to be really picky on spelling sometimes, those 2 words are only 1 letter apart, but they mean something very, very different. Sulfite is the polyatomic ion SO3 with a -2 charge. Sulfide is the ion that we get by turning sulfur alone into its ion. So sulfide is S with a -2 charge. 1 letter makes a big difference in what ion we're talking about there. So if copper has a +1 charge, and we know that because of its Roman numeral, and sulfide is a -2, sulfur is a group 6 nonmetal, so it needs to gain 2 electrons to have a full outer shell. The correct formula for copper 1 sulfide would be Cu2S. Rafonso, is that making sense?
Yeah, I'm still like, figuring out how to do it. I'm still lost a little.
Do you understand how the charges balance?
Yeah.
Okay. So let's slow down a little bit and talk about each one of the parts of this name. So first of all, gallium is the metal. If we find gallium on the periodic table, here it is. Part of group 3. So we know that gallium is going to have a +3 charge when it's part of an ionic compound. And then nitride, the suffix "ide", normally means that we're talking about just a nonmetal ion all by itself. There is one exception to that. Cyanide is not an ion that's just one atom. That's a polyatomic ion, all right? Don't shoot me. I am not the one that named all these things. But generally speaking, an "ide" suffix normally refers to just an atom with a negative charge. So nitride is nitrogen, a nonmetal, when it becomes an ion in an ionic compound. So here's nitrogen, group 5, which means it needs to gain 1, 2, 3 electrons to have a full outer shell. So nitride, the nitrogen in nitride, should have a -3 charge. Well, that's pretty cool. A +3 and a -3, those are already charge balanced, which means that we should only need one of each of them in the formula for gallium nitride. Haley, you're nodding. Does that mean you got that one right? Awesome. Note that a 1-letter change. What if I had asked you to give me the formula for gallium nitrite instead of gallium nitride? That's a big difference. That 1 letter means now we're talking about nitrite, the polyatomic ion that's NO2-. So gallium nitrite would have to have 3 of those nitrites along with the 1 gallium 3+. So does spelling count? Sometimes it has to, all right? Because 1 letter can make a huge difference in the formula that we're talking about. What about calcium nitrate? Calcium is a group 2 metal. So it has a +2 charge as part of an ionic compound. Nitrate is one of those polyatomic ions that you guys are going to have memorized in another couple of days. And it has the formula NO3 with a -1 charge. So putting those two together, it looks like we're going to need 2 nitrates for every 1 calcium in that formula. Making sense so far? Okay, so let's move on to naming now. What 2 things do we have together here? Our metal is palladium. And what's the negatively charged thing that we have with it?
Bicarbonate?
Not bicarbonate. Bicarbonate is HCO3 with a -1 charge. This is just plain old carbonate. Now, oddly enough, there is no such thing as CO2 with a -2 charge. That doesn't exist, at least not in a stable form. If it did exist, what would we call that polyatomic ion? CO2 with a -2 charge. This joke may just be too old for all you guys. There's a joke hiding in here, I promise. What's CO3 with a -2 charge? Haley, I can't hear you. You're muted.
I know, I'm sorry. I constantly talk to myself. I was like, that's one of the ones I was trying to figure out.
CO3 with a -2 charge is carbonate. So what would CO2 with a -2 charge be? Carbonite. Anybody ever hear of carbonite before? Do you know what that is? From the world of science fiction. That was the stuff that Han Solo got frozen in Star Wars. Duh. All right. So if there was actually CO2 2-, that would be the stuff that Han Solo got frozen in Star Wars. But it doesn't exist. All right. It's always fun, though, if there's like some pseudo-scientific explanation for the science fiction thing that they're doing. So anyway, now we know the formula of the stuff that Han Solo supposedly got frozen in, even though it doesn't exist. But CO3 with a -2 charge is carbonate. So that helps us because we have to be able to figure out what palladium's charge is to name this compound correctly. Palladium can have more than one possible charge. So we have to be specific when we name this compound that has palladium and carbonate in it to tell what the charge of palladium is. And since each of these two carbonates have a -2 charge, that must mean that the palladium has a +4 charge. Does that make sense to everybody? So that one palladium with 4 positive charges is enough to balance out those two carbonates that are each -2. So because palladium has a +4 charge here, we would name this compound palladium 4 carbonate. The next one is considerably easier. We have rubidium, a group 1 metal, and we have the polyatomic ion cyanide. So because group 1 metals are always +1s, we don't have to worry about what rubidium's charge is. We don't have to say the charge of rubidium because it's always +1. So we would just call this rubidium cyanide. Like virtually all cyanide salts, it is deadly poisonous. This next one's fun. Again, I gave you the clue that osmium can have various charges as an ion, which means that when we name this compound, we have to be specific about what osmium's charge is. We have to label its charge with a Roman numeral after the name of the metal. So how do we figure out what osmium's charge is? We have to figure out what it's with. It is with 4 oxygens. So when we look at oxygen on the periodic table, oxygen is a group 6 nonmetal, which means it needs to gain 2 electrons to have a full outer shell, which means each one of those oxygens is a -2. And there are 4 of those oxygens. So we have a total of -8 for those 4 oxygens. Because of that, that one osmium has to have enough positive charge to balance out that -8 charge, which means the correct name for this compound is osmium 8 oxide. Now, Logan, if I was naming, or if I wouldn't give you the name of this compound and ask you to write a formula for me because I wouldn't expect you to have the charge of zinc memorized. But if you already know that zinc always has the same charge, that's a clue that we're not going to need to write the charge of zinc after it. So in this case, we just have to name the compound by naming the metal, zinc, and then naming what it's with. So if it was just some sort of non-metal, we would truncate the non-metal's name and give it the suffix "ide." So if it was ZnCl2, it would be zinc chloride. But in this case, it's with SO4 with a -2 charge. So this is zinc sulfate.
If you by actually put zinc 2 sulfate on a test, would we get docked for it?
If I went to all the trouble of telling you that it always has the same charge, and then you gave me the name or the charge anyway, even though you know from the context clues that you don't have to, yes, you get the point docked off.
Okay.
So I went to all the trouble of giving you the context clue to tell you you don't need to do that. So don't do it.
Okay, but you will give us the context clues on the
I will
test.
give you the context clue.
Okay.
Yep. Hopefully those examples have helped you guys out. So most of chapter 3 is really just, can you write the correct formula for an ionic compound? Can you name the ionic compound correctly if I give you the formula? Now, there's a lot to that, right? We have to understand how metals react to make ionic compounds. They do that by losing their valence electrons. We have to understand how nonmetals react to form ionic compounds. They do that by gaining valence electrons until they have 8 in their outer shell. And we also have to understand that there are some small groups of atoms, the polyatomic ions, that can take the place of a metal or a nonmetal in an ionic compound. But that's chapter 3. Yay, we did it.
And cations and anions are like just
Hey, yeah, I don't think I've ever actually said that, but in the video, in the videos for chapter 3, it's in there. So it turns out that the special name that we give for positive ions, we call those cations. I can't remember when it was. It was a couple of years ago. Somebody kept asking me, what are cations? And I was like, what's a cation? What are you talking? He read this and was pronouncing it cation instead of cation. So anyway, we all had a big laugh about that after we figured it out. Never be afraid to pronounce something wrong. That just means that you read, which is awesome. All right. So this is a supportive class environment. You'll never get laughed at for pronouncing something wrong, but I want to help you pronounce things right so you sound really smart to everybody else once you're done with the class. So that's a cation. Positive ions are cations. Negative ions are anions. So yeah, just vocab. Anything else I can help you guys with? The cool thing is, like at this point in terms of recitations, we've covered all of the material that's going to be on exam 1 in a recitation at some point already. So you got time. Our first exam is going to be next Friday. You have time to like let it stew a little bit. Oh, that's really bad, Jennifer. I can't handle it. Oh no.
The worse it is, the easier you'll remember it.
I know. Oh. That one just twists my stomach into a knot. Even
I know you have a hard time with that stuff.
I do. I really do. Yeah. That completely derailed my train of thought.
Sorry.
No, it's okay. That's why I can't do mnemonic devices, because either they're too subtle to remember, or they're such bad puns that they make me want to throw up, and then I can't focus anymore after. So we've got about a week until exam 1. We've got time to review anything that you guys want to review before exam 1, and that's great. We do have to quick go through lab number 3 tonight. All right, so that won't take very long at all. Rafonso, do you have a question?
Yeah, because my calendar says Monday, is it October 12th? The test, chapter 1 to 3. If
I don't think it says Monday, does it?
Mine says Monday. I'm not sure, but
Hold on. I'm gonna go to, are you talking, I don't know.
The week beginning October 12th.
Yeah, so the way that our Canvas page is structured, I try and keep the schedule a weekly schedule so there's some flexibility to it, because sometimes people take longer or not as long with some things than other classes, right? I don't want to legislate down to every hour that we spend together, because every class needs help with different things when they're going through this material. So when I do the course schedule, I only make it a weekly course schedule. So right here, it says next week, there's a test over chapters 1 through 3. I don't even say what day it is, but I'll probably push it till Friday to just give you guys as much time as possible. Okay?
okay.
So anyway, this schedule is a weekly schedule. The only thing that has actual dates in it are the due dates for Alex that are over here on the right.
Okay.
And I will definitely post a Canvas announcement also that confirms that exam date and also the window of time that you have to take it. So you'll have 2 hours to take your exam and then turn it into a PDF and submit it. But you can start your exam anytime between 9 a.m. and let's say like 9 p.m. on that Friday. It's a pretty good exam window. So pretty much everybody should be able to do that. Renee, yes?
Where do you have information? Because I would hate for to ask you to repeat yourself, but as far as like how it's taken, the format, how it's submitted, those kind
I
of
promise that in the announcements leading up to the exam, I'll have a comprehensive set of instructions posted ahead of time so you can look them over. All right. There won't be any surprises. Nobody has had trouble following the instructions for how to do those exams that we've done in the past. So it'll work. All right.
Thanks.
Yeah. I understand exams are stressful and taking them remotely is like double stressful. Trust me when I say trying to figure out how to write an exam for people to take at home is also really stressful. So there's like plenty of stress for everybody, but I promise you'll know what you're doing. Okay.
Okay.
And if you don't know what you're doing, if you get stuck, I'll be like hovering around on that Friday looking to see what people are doing. And you can always text me and I can bail you out. Okay.
Okay. And will the windows of time throughout the quarter be the same? Like, or is it just how does that work?
It should, the windows should, I mean, it'll always be a 1-day exam window and it'll be open basically like all day that day. So from 9 a.m. until 11 p.m. or something.
Oh, I see. And then, but we just have 2 hours to take it within that window.
Exactly. So that means you should start your exam before 9 p.m.
Yeah.
That makes sense?
Yes.
Okay. Okay, so what I'm going to do is I'm going to stop screen sharing. I'm going to stop recording.